Okay, let's do this. This is chapter 3, homework number 3. Robert believes the line graphed at right are perpendicular, but Mario is not convinced. What is the slope of each line? Explain how you know whether or not the lines are perpendicular. Right? To find the slope, you are going to have to find the 2 points on each graph and figure out the change in the y over the change in the x. Right? So let's start with, guess that's the biggest it gets, but let's start with this line here. Okay, so I need 2 points. I'm going to use this point right here. And looks like this is the next point. So the change in y is going to be, I'm going to go down 1, down 2, down 3, and over 2. Right? So for that line, the slope is the change in y over the change in x, which is the change in y is down 3 and the change in x is over 2. Okay, for this line right here, I'm going to use this point and I'm going to use this point. Okay, so the change in y is going to be up 1 and the change in x is over 2. So this line right here, the change in y over the change in x, the change in y is going to be up 1 and then to be over 2. So now since I know both slope and I need to look at these numbers, and for them to be perpendicular, they have to be opposite. So they are. This one is positive, this one is negative, right? And they have to be the reciprocal or the flip of each of these. And you saw that's 1 over 2, and this is 3 over 2. They're not reciprocal. They're not flips of each other, so they are not perpendicular. Right? So I'm going to say the lines are not perpendicular because the slopes are not reciprocals, which means flip of one another. Remember, for it to be perpendicular, it needs to be reciprocal and opposite, and they are opposite, but they're not reciprocal. So I'm just saying that they're not reciprocals. All right. So let's look at number 33. So it says write an expression or examine the rectangle at the right. Write an expression for the perimeter in terms of x. So you look here. Wow, this wants to keep going back up. You look here. If the top is 2x, then that means that this bottom is also 2x. If the right side is x plus 3, then this side is also x plus 3. Okay. All right, so write an expression for the perimeter. So the perimeter, so this is A. So the perimeter equals, I'm going to start with x plus 3, and there's another x plus 3. Then I'm going to add 2x, and I'm going to add another 2x. Okay, so that's an expression in terms of x. Okay, assuming the perimeter is 78 centimeters, determine the dimension of the rectangle. Show all your work. All right, so part B says, hey, now we know that the perimeter is 78, so I'm going to call this 78. And now that's equal to all of this. X plus 3 plus x plus 3 plus 2x plus 2. Then I'm going to go ahead and do some work. So 78 equals, I'm going to go ahead and add all the x's up. So that's 1x. That's 1x, 2x, 3, 4. Oh, forgot. And then 5, 6. So that's 1x, 2x, 3, 4x, 5, 6x. So that's 78 is equal to 6x. And I'm counting all the 3's. So that's 3, 4, 5, 6. And that's it. So it's going to be 6x plus 6. Okay, so what I'm going to do is I'm going to go ahead and subtract 6 from both sides. So this will be 78 minus 6 because I need to subtract 6. I'm going to start right here. So 78 minus 6 is 72 equals 6x. And then I'm going to go ahead and get rid of that 6 because I need to solve for x. So I need to do 72 divided by 6. And if you don't know it, use a calculator. But that comes out to be x equals 12. So the x is just 12. Okay. So that means you're going to put 12 in place of x. So the dimension is going to be, so instead of x, you're going to put 12. So this side is going to be 12 plus 3 or 15. That means that this side is 15 also. And this side is going to be, you're going to put 12 right here. So 2 times 12 is 24. And this side is also 24. So this is a 15 by 24 rectangle. Okay. Verify the area of this rectangle is 360. So if this is a rectangle, and if we want to know the area, we have to multiply the 15 by the 24, or the length times the width, to get the area. So on part C, area equals length times width. In this case, it's going to be 24 times 15. And use a calculator if you don't know, but if you want to do it by hand or not, but I will have 360. So that is the area. Okay, examine the figure, the axis at the right. What happens if you rotate the figure about the origin 90 degrees? So you see it when I'm doing it, but 90 degrees is when I take this. I'm going to go ahead and copy this. And I'm going to go ahead and take it, and you see my little green handles on top right here. If I take it 90 degrees, that's actually going to end up same thing, right? So if I say rotate it 90 degrees, it's going to be the same thing. Okay, that's 90 degrees. 45 degrees. So let's start over. So let's take it. See my green handle? I'm going to start over. 45 degrees is half of 90. So I'm going to rotate this. And it's going to hit right in the middle between the 90 degrees. Homework's a little slow today. Oh. So 45 degrees. There it is. 45 degrees is right there. And that's 45 degrees. So if I take my little green handle and rotate it so the green handle is right there, guess what? It matches exactly the same. So 45 degrees, same shape. Okay, it's been rotated, but it doesn't look like it's changed. And then how about 180 degrees? Right, so it's 180 degrees. Okay, 180 degrees means that I'm going to take it right here from top and I'm going to go to the bottom. So basically flip my paper upside down. So that's 90, that's 180 degrees. Look at it. Same shape again. Pretty crazy, huh? Okay. By what other angle could the figure at the right be rotated so that the shape does not appear to change? You can say that the shape, right? You can, for any of these, I said same shape, but you can say the shape does not appear to change. Well, you can do this. So we can redo this for 90 degrees, which is that much. Okay. We did it for 45 degrees, and you see how I started and how I ended at the tip of the star. Okay, 45 degrees. And look, beginning and the tip is the same, so it's 180 degrees. Okay, but what else can you do? Well, we can do this. We can do from the right here. We can do here. So that's 90 plus another 45. So this part is 90, and this part's 45. Okay, so you can also do this with 135. Okay, what else? We could do this with 90 plus another 90 plus another 45. Okay, so that's 180, 225. Or you can do 90, 90, and 90, which is 270. Okay, and you keep adding 45 or 90 from there. Okay? Well, the shape stay the same no matter how many degrees is rotated. This would be no, right? So I would say no, the shape will only stay the same when rotated about every multiple of 45 degrees. Okay, meaning that it has to be a 40, like multiples of 45, 45, or 45 plus 45, or 45 plus 45 plus 45. You get the idea. So, for example, it will only stay the same when so if I rotate this 145 degrees, you get that. 245 degrees, 245, you get this. 1, 2. 345 degrees is 1, 2, 3. Okay. 445 degrees, you get that. 545, you get this. 645 degrees, 745, and 845. That's 360. Okay. If you only rotate it, let's say 10 degrees, it's going to end up looking like this. That's about 10. See how it doesn't line up? You rotate it 80 degrees. Okay, 90 is all the way here. But 80 degrees is about right there. So it doesn't line up. So they will only stay the same shape when